Okay.
It's the nanotechnology.
It's the nanotechnology. Got it. He's like basically Spider-Man.
Literally.
I mean, it was like really, really cool. He's married, by the way. Yeah. Yeah, his sister was that Audrey?
Yeah.
Yeah.
I played tennis with him back when I was like 9.
Yeah.
Like occasionally.
Yeah.
Well,
I thought that was cool having a picture of my classroom. I thought that was very inspiring. Just think, maybe you guys can come and do a guest speaker someday. Okay. You missed no notes.
For the data table, do you want us to turn in like the same
Ooh.
ones that we used to practice, or the test one?
Either one. It doesn't really matter. It's the same calcs for either one.
Finish like the whole procedure.
I don't care. It doesn't matter. I just want to see sample calcs for one. You know who equals, what does LH stand for?
Lucy's husband. But
Oh, got it.
nanotech.
Nanotechnology. You could just put love nanotechnology.
Oh, yeah.
We can know what it means. Yes.
I'll put them hard.
If we use the test one, can we get like the exact so we can?
Oh, you don't have to do percent error. That's not
Okay.
on any of them.
I thought everything that had a calculator.
Oh, wait, you did have to do that in the practice. So yes, you need to have one where there's percent error.
If we put a percent errors on the one that we did on accident, like because we didn't know, are you gonna take points off?
You did extra work?
Yeah, can I get extra credit? I feel like I did
Sometimes-
way too much.
Sometimes I'm sure if you put like more than you need to, they'll take points off.
I will never take off for you doing too much.
I like getting more.
wait.
Whoa.
So on the calculations, we can use percent
I think that HCL practice you would have had to have.
Well, yeah.
Yeah.
I have to, like, we need to show,
I'm just looking for nanotech.
Yeah.
do we need to show percent error, like, for each thing?
No, just one trial. Okay. So, how was tag day? Did the band make a lot of money?
I did. I was a money counter. We made 7,400.
That's a good day for just begging.
I thought I did for like 4 hours.
Yeah. Okay. Here's the good news. Chapter 5 is mostly review.
Yay.
So this is gases. How do you spell gases? G-A?
SSES.
Is it S-S-E-S?
No, it's SES.
GASSES.
It's
Add another one.
No.
SSES. No.
I think that's right.
It's wrong. Look it up.
Chapter 5 gases. So a lot of this is going to be a review. So first of all, we have to talk about what an ideal gas is. So when I say an ideal gases,
How do you spell regular? Yeah.
we're not talking about regular gases. We're talking about ideal gases. Ideal gases follow the KMT. What is the KMT?
Great, I remember that.
The kinetic molecular theory, which says the following. Number 1, particles are always what? Yes. Particles always in motion. And we also know that everything is made of particles, right?
Yeah.
Yes. 2, the speed of particles. The speed of particles is directly related to what? To, I want to specifically say the Kelvin temperature. So we're going to be doing some plus what this chapter?
275.
Some plus 273s.
Oh,
0.15.
We're just going to do 270. AP Chem accepts 273.
Really?
Yes.
That's corrupted.
Well, that's fine.
Okay.
Wait,
Yes.
what is KMT again?
Kinetic molecular theory. So, number 1, particles are always in motion. I'm giving it to you right now. 2, speed of particles directly related to Kelvin temperature. 3, collisions of gas molecules cause what? Yes. Cause pressure. And 4, gas molecules have no volume or attraction.
Dang
They have mass.
it. Okay, well,
You got to know this. You got to know those 4 things. Probably the first 4 points of the next test.
have no volume.
No volume or attraction. All right, we're going to play Pictionary. First person to guess what I'm drawing gets a piece of candy.
Got it. I'm locked.
I'm not gonna.
Are you ready?
Particle.
No.
Gas.
A tub.
Square.
A
Water.
rectangle. A
Water.
tub with a tube.
Thermometer.
A boat.
Kit Kat.
Hey man.
Oh yeah, I'm not getting this.
Oh my
The pencil launcher that
I
they were
know what
talking
it
about.
is. It's the thing that we did.
Oh
Oh my god, dude, no! It's it's the oil thing. It's the thing with the oil. It's the
Oh, a
thing.
thermometer.
Yes, a barometer. That is correct. Good job. This is a mercury barometer. Coming up and grab your prize. All right?
Do we need to draw that?
Yes, draw this. How does a barometer work? Well, we have a tube upside down. We have a tube upside down, and I have a sealed vacuum, a sealed amount of particles up here. And what happens is, what's going to push down on this mercury?
Gas.
Molecules in the air, yes. Molecules in the air collide with the surface of the metal, which this is a liquid metal. How is it possible that mercury is a liquid? How do you know that? It's blue on the periodic table. There's only 2 on the periodic table that are blue, which are mercury and bromine. Those are the only liquid at room temperature.
Specifically for metal temperature.
Anything.
What about gallium? Why is blue?
There's only 2
Liquid.
that are liquid at room temperature.
What about
What
gallium?
qualifies as room temperature?
We're going to talk about that. We're going to talk about that. So molecules in the air collide with the surface of the metal.
Oh, wait, never mind.
And what do they do to the mercury? Where are they pushing the mercury? And push/blow mercury up the tube.
I just spelled out the word slash.
Here's why. You spelled slash, that's unfortunate.
Push slash.
Here's the thing about gases. Gases only flow from what to what?
Low to
High to low pressure. This is how I always teach this to my freshmen in AP Chem. Nothing sucks. Everything blows. All right? If you can remember, nothing sucks, everything blows, you will always remember this. Because this tube is not sucking the mercury up. The pressure from the atmosphere is pushing, it's actually blowing the mercury up. Why? There's low pressure up here in this little piece. There's higher pressure on the outside. So trying to push the mercury up the tube.
Wait, so if you breathe in, it's just the atmosphere.
When you breathe in, what are you doing to your lungs?
Expanding.
You are expanding your lungs, correct? Creates what type of pressure in your lungs? Low pressure. So there's actually air blowing into your
Is
lungs.
that why it's like hard to breathe when air is like blowing right in your face because it feels like there's like too much?
Yes, also that's why people work out where for the Olympics?
High altitude.
Higher altitude, right? Because there's less what pushing into your lungs? Less pressure, so it's harder to work out. That gets you better conditioned.
Yeah.
Just science.
Is that why baseball fly farther for the Colorado Rockies?
Yes, Mile High Stadium. Rocky Stadium, there's just less particles pushing down.
Guardians are going all the
They
way.
just don't swing.
I feel good about the Guardians.
Tyler, I'm going to game 5 on Saturday.
Ooh, nice.
Which of the Guardians went to the Colorado Rockies? We just absolutely just pound balls.
That's historically the stadium with the most home runs.
That's
So-
crazy.
Yeah. If what?
Like, what if we don't go to game 5?
If we just sweep them?
Yeah.
He'll get his money back.
Game 5, yeah.
Game 5 could be a big deciding game. I think we take 1 out of 2 in New York, and then 3 out of 3 at home. Yeah. Be awesome. Then somehow the Mets win, and it's Francisco Lindor's homecoming for the World
He was
Series.
my favorite player, and I literally cried when he left. He's a traitor.
Francisco Lindor,
I had his jersey. I had
nanotechnology.
So was my mom.
Where are we ranking that?
No, Frankie Lindor's on the hate list, bro. I love him anyway.
Okay, FL.
Okay, I need to say I love.
Okay, so let's come up with a couple examples. So, if I have a glass of,
No, or is it?
what is this?
Uh,
I'm gonna keep playing Pictionary.
bucket.
Oh, that's the
Light refraction.
oh, that's
it's the light
Refraction.
displacement fraction.
Glass of water with a straw.
Yeah.
Yes.
Refracting light.
Glass of water with a straw, there's refraction here. All right. Do I suck liquid into my mouth?
No.
No. What do I create in my mouth? Low pressure. What does the atmosphere do? Pushes the liquid. All right. I just wanted to. All right. The air pressure pushes the liquid into my mouth. This is why if I have a cup with water, like so, and I have a straw, one straw on the inside and one straw on the outside, can you drink that water? Why? There's no pressure differential, right?
Wait, can you say that again?
If I have a straw in water and a straw outside of the water, you can't drink it.
If you put 2 straws in your mouth and one of them is out.
Well, no, because
Wait, what?
All right, Lucy, come on up and try it.
So maybe.
Oh, you haven't had it prepared.
I'm agreeing.
Come on up and try it. Danny's gonna do it. All right, one straw in, one straw out. Make sure that everybody can see. Wait, turn around so everybody can see. Or do you want to be on the video for this? He got
just drink.
maybe a little bit,
Okay, but
but you also can't like seal it. You can't like push this.
I'd push what?
Okay. Are you getting much there?
I mean, it's like some.
It's some.
But
It's not perfect,
Yeah, you can't get water because.
but like you.
I defy all laws.
Wow. Give him a round of applause. Danny broke physics.
He was pitching another
So
show.
I did this.
You can sit back down, but you can take that with you if you want to. But you can say he could not drink it easily, right? He was able to get some scraps, right? Able to get some scraps. Now, because of this, all right, what am I drawing now for another piece of candy?
Line, square, bucket,
Thermometer.
toxic waste,
A straw. Barometer. Barometer.
tube,
A water jug.
a
A
cone,
water
fountain.
fountain. A fountain.
A person jumping into a pool. Cliff jumper. Mr. Miller, you skydive.
Jake.
Jake
Jack acetate, yes.
jumping into the water.
Jake jumping into a pool.
Yes.
Spitting into
Ella got it. All right. This is Jack. Yes, you can. This is Jack acetate
I think I need to get a piece of candy for.
with a straw from the top of Worcester High School into a cup of water. There must be a what for the length of this straw. There has to be some kind of limit, right? Because what's pushing down on us?
Gravity.
No.
Oh.
We live at the bottom of a sea of air, right? There is a limit to how far our atmosphere can push that straw up. No matter how hard Jack, quote, sucks, really he's creating low pressure, the atmosphere can only blow up so much water. Anybody know the length of this straw that it can go?
25 feet.
It's 33 feet.
Oh.
All right? Yes, it is a proven thing. All right? You cannot have a straw longer than 33 feet in Earth's atmosphere. Because Earth's atmosphere can only do this much work. What?
Oh, that makes sense.
That's how much that's the most pressure.
Danny needs to defy that.
Yeah, I feel like
We should have had a 33-foot. All right, I've got a ladder outside. No,
Wait, are you saying like, you're saying like upwards?
upwards.
If it
So
was
if
over
it's
there,
obviously-
Now, if it's flat, it would
No,
work.
but like horizontal.
Wait, so what, like,
Danny
no,
could probably
no,
do that.
What's that?
what, like, no, should we write about?
I would. This is just saying that Earth's atmosphere can only do 33 feet worth of work, at most.
If a person was sucking on the straw.
If a person was sucking on the straw.
Well,
Now, if a T-Rex was sucking on the straw, I don't know.
okay.
No, actually, it doesn't matter. It doesn't matter who's
I'm
sucking the
thinking
straw.
like pipes.
What?
Like pipes.
It doesn't matter who's sucking it. Good point. Let's talk about pipes.
Yeah.
All right, let's talk about pipes.
Like water.
Added pressure behind.
This is down at the golf course. What am I drawing now?
A sprinkler.
Oh,
No.
I got this.
All right, this is down at the College of Worcester golf course.
Hole number 3.
Oh, I don't.
All right.
A flag, a little,
Umbrella.
Sprinkler.
How is that a sprinkler?
Sprinkler.
A
Yeah.
tree that's
What?
sprinkler washes your golf cart.
An oil thing?
Water fountain. Water fountain.
It's a water pump, right?
Ball cleaner.
You guys ever see down at the College of Worcester, like the pump water?
Oh, the ball cleaners?
Not the ball cleaner. It's like the thing that you pump.
Yeah.
There's also one out here by the greenhouse.
Oh,
Yeah.
those things, okay.
All right.
The thing
Derek
that
brings
rams
up-
tires.
Yeah, the things that Rams has for the ducks,
Ducks, dude.
right?
I was cruising with the ducks.
Okay.
I was sending ducks out.
Proud of you.
Yeah, thank you.
Really proud of you. Now, guess how far this can be in the ground?
33 feet.
Only 33 feet. Because that's how far the atmosphere can push back. Only 33 feet. Do you want to drink this water at the golf course
Yeah.
on a dry day? Do you want to drink it after a rainy day? Why?
Because the water, it gets it from the muddy stuff.
What do they put on the golf course?
Chemicals.
Tons of chemicals.
Why is it safe on a dry day though?
Because on a dry day, nothing has leached down 33 feet. It's probably okay to drink. On a wet day, all those chemicals they put, is this a very deep aquifer? No. All right? So on a dry day, it's going to be okay. On a wet day, after all those chemicals have leached down in here, there's probably going to be chemicals in there. Or just don't drink water in a well
What if you turn it
on a
into
golf course.
Or Spider-Man.
Well, Spider-Man with plasma and nanotechnology, anything's possible.
Wait, so what if there's added pressure behind? So like, don't water towers work? Then it takes the pressure that it takes to drop from the top of the tower and it uses that to go back up.
So water towers, what they do is, who here's an AP Enviro? No one here's an AP Enviro? You are?
I am mentally.
2 people are. You guys are going to go to the water treatment plant eventually and figure this out. They clean the water at the water treatment plant and they pump it. They physically pump it up to the top of the water tower.
Do they like
And then all the water that's come out of your faucets is just gravity driven.
That's what I was gonna say.
Gravity just pulls it down. So, are you ready for one more picture?
Yes.
All right, what is this device? I don't think anyone's going to get this piece of candy. Are you guys ready for this?
I got this.
All right, here we go.
Locked.
where? Where?
It's a box with a
Shopping bag.
A button?
Big button.
What'd you say?
Shopping bag.
No, I thought you got it. That was really close.
shopping cart.
Coffee.
Was it like a
Shopper.
shopping closet?
Shop bag.
Shop vac, yes! Oh my gosh, yeah, that was incredible. All right.
Shop bags are not school.
It's like a it's like a
What
circle.
even is that?
This is a shop vac. The little thing on the top, the circle,
Yeah.
right?
That's done, bro.
That was.
You don't know what a shop bag is, you're not cultured.
Ella is going to be my partner in Pictionary from now on because that was like not a very good picture.
I'm lit.
Now, am I sucking up dust in my vacuum? No. What is blowing the dust up? Air pressure. What type of pressure am I creating inside my shop vac? Low pressure. When do I want to sweep if I want to really impress my wife?
On a cold day.
On a high pressure day.
When there's a lot of dust.
If I sweep on a high pressure day, my vacuum will actually work better.
Really?
Yeah, because there's more pressure pushing that dust into my
How do you
vacuum.
know if it's a high pressure day or
Today is not a high pressure day.
How do you know?
Usually low pressure is associated with rain. High pressure is going to be your bright sunny days without any clouds.
So,
Yes.
how does like the electricity make that happen?
So the electricity is turning this pump, which is blowing air out. There's less air inside the vacuum than there is on the outside.
There's like a fan in there. or something?
Yes. This is essentially just a fan that blows air out the back. Yeah. Low pressure, you are blowing dust into your
I can't
vacuum.
believe you didn't know what a shop vac.
Right.
Is that how people have like the window, like and fans in their window, and it like that makes like air conditioning at like college campuses?
A fan in a window.
Yeah,
I mean, sometimes there's window units.
that's what I mean, but it's like a big fan.
That window unit is just like evaporating water over coils and blowing cold air back in.
Oh, okay.
So that's like not this.
Okay.
But if you had a fan, right, like in your window,
Yeah.
like when I lived upstairs in my parents' house, a lot of the time the fan would be blowing even if it wasn't on, because I had a lot of hot air on the inside and cold air on the outside. So the hot air was just trying to get out because high to low. Okay. All right. This next picture. You guys ready for this? All right. This is happening at my dream house.
Whoa, I got to be.
All right. Here's my dream house. Okay. Obviously, it has 2 stories. That's my daughter's rooms up there. Okay.
Are we drawing this?
Yeah, you're drawing this. Okay.
I like the pictures, let's keep up.
I know. So, what is on the back of my dream house back here?
A porch.
Pool.
Nope.
porch.
It's not a pool.
A big yard.
Have you ever seen a double?
Ram tires.
A big yard
Oh, wow.
with a turtle shell.
A bucket?
A pool?
Oh well.
What am I watching right here?
TV.
I'm watching TV
Backyard TV.
in my hot tub. Yes! You can get a piece of candy. All right? Now, what does this have to do with the picture? Not a lot. But I live in the country. If I live in the country, what do I have to dig to have water?
Well.
A well. Who here lives in the country? It's the third one down. Anyone live in the country? Do you have a well?
City limits.
Okay, you have a well. All right. How deep do you want the well to be?
32 feet.
More than that.
33 feet is not a very deep well.
You're gonna get.
If you want to have a safe drinking well, you usually want this, so down here, all right, in here I have to have a pump.
Well,
right?
well.
Here's my pump, because this is actually probably going to be 186 feet deep. All right, a good water well is going to be 186 feet deep. That's how you get down, what? How?
Yeah, like how's it more than 33?
You drill, and then you have to have a pump at the bottom that's pushing the water back up.
186.
So now I have an electric line running down here, and I have a pump.
I have a question.
Yes. You have to have a pump at the bottom of the well to push it back up.
I have a genuine question.
Yes. 186 feet. 186
Where
feet.
does the water just, is it just?
So down here, this is the aquifer, right? So there is water in the ground, right? In between all of these little pieces of stone, essentially. So there's underwater lakes all over the
You're
place.
telling me that pump can take that much water out of that rock?
Well, the water's just sitting here. The pump is just pumping it up the pipe.
Well, the water's just sitting there. I'm just,
All the pump is doing is pushing it up the pipe. What?
is the water just pooled there?
Yeah.
So there's like a layer around the earth where the water's just.
Yes. There's massive underwater lakes and aquifers. Yeah.
That's why
Yeah.
at the beach and you did it. I love that you didn't know that. That's
We're learning new things.
Like, we could be
We're
a
learning new
fucking
things.
right now.
All
right.
I thought it was just like
Now,
straight stone to the.
if your lining on your pump breaks right here,
Uh-oh.
all right, what happens to your shower?
It's gonna
Another
explode.
shower.
Your shower turns into a mud shower.
Ew.
All right?
Yeah, money shower.
Turns into a mud shower because there's dirt on the outside of this. The dirt gets in there, and then what do you have to do? You have to dig a new well.
Are you serious?
That's not cheap. All right? So,
Like
um,
$1 trillion.
no, it's just like several $1,000s. It
Wait,
just
what,
isn't cheap.
what happens when your well dries up? I heard that.
So when your well dries up, your aquifer is empty, right?
You gotta wait for it to go back.
So you have to wait for it to either rain, or like when you're in California right now, you're getting water via irrigation on top. Like, this is a major issue in California. Yeah, irrigation. Yeah, we're getting it. We're getting it. Thankfully, here in Ohio, we have enough rain. All right. Now in southern Ohio, this summer, there was like a period we got like no rain for 3 weeks. They were on like a no water use except for like bathroom, shower, like no water in your yard, stuff like that, because they were worried that some of the aquifers were drying up down there.
Don't they do that in California a lot?
All the time. All the time.
Why do you have to dig a new one? Right
No, on this one, I was saying if you get a hole in it
up?
and you get the mud. Once this fills with mud, you're done. You're done.
So
You're
are the people
cooked.
who are like in the hurricane now, they're really not gonna dry for a long time then?
Yeah,
For what?
people in the hurricane,
Oh my.
they have lots of stuff down there. The biggest thing I saw about the
Well,
hurricane,
yeah, obviously, but I'm saying like in the future, there's already a bunch of water.
they got plenty of water down there.
Isn't it
But the thing with, what's that?
Isn't it salt
It
water?
gets
This
pure.
is like
It gets
earth-
filtered
this
through the
is
ground.
like earth water right now. What do you
Come
mean?
on,
Yeah.
Dan. Even I knew
It's
that.
actually just dirt.
The biggest thing I saw about the hurricane is many houses had 8 feet of sand from the storm surge. So that sand probably filled a lot of the wells. So those wells were also ruined. Now, last picture for the day. All right? Are you guys ready for this? Okay. So here we go. I'm going to have this going way down here.
Are we drawing this one?
You're drawing this.
Eiffel Tower picture.
Eiffel
Leaning Tower pizza.
Telescope.
Specifically, what is this in Worcester, Ohio?
It's a rock.
It's a rock.
It's a big
I don't know
dog.
about that.
A constellation.
Dog with 2 heads.
It's a mean snail.
This is somewhere in Worcester, Ohio, this thing.
What is that?
I'll give you a hint. This is 5,000 to 7,000 feet deep.
Oh, where they make the water.
Is that like a
Right.
water park?
Freeland.
It's not a pool.
Not a pool. Look what this is connected to. This thing is going up, down, up, down, up, down, up.
The water
Clock.
treatment plant?
A what? It's an oil pump. Yes. Thank you.
That's everywhere on Earth.
This is the purple pumper.
That looks nothing like it.
Oh, yeah, it does.
It's right in Charlotte.
It's pretty accurate.
Driveway.
It still has the purple pumper.
All right. How does an oil pump work? Because an oil pump is 5,000 to 7,000 feet deep. You have 2 ball bearings down here at the bottom of your pump, and these ball bearings are squishy, right? It pushes these together, they squish together. Creates what kind of pressure? Low pressure. Oil flows in. Then when they spread out, guess where the oil goes? Back up. These are how those oil pumps work. There's a massive rod here that pushes balls together, squeeze, squeeze, release, squeeze, release, squeeze, release. That's how these oil pumps work. It's kind of cool. All right, and then you're going to have some kind of tank over here that's going to be collecting your oil. Going to be collecting your oil. Pretty cool.
How do they dig that?
How they dig? Drills. Got a drill.
Yeah,
They just like
they
send it
actually
down
just
there.
keep jumping. and-
Yeah. You just keep, what they have to do is they have a drill bit, then they connect another drill bit, and then they connect another drill bit, and they just keep connecting pieces until it gets deeper. I just watched this summer, is it Armageddon, where they have to drill on the asteroid? It's Bruce Willis. Yeah. Yeah, they hire this ragtag crew of oil drillers, and they go up and they have to drill this asteroid to blow it up. They put a nuke in it. It's a good one. Yes.
Okay, so you know how like in Western North Carolina, how like all the mountains have like switchback roads to get up?
Yes.
So, because a lot of my family lives in North Carolina, they
Uh-huh.
have like mountain houses or whatever. And like their houses are fine because they were up on the mountain.
Uh-huh.
But the switchbacks got so taken out by the rain
Mhm.
that like they might not even be able to rebuild them.
Yeah.
So it's like they got out, but it's like their houses are just like stuck up there because
Yeah.
they really can't get up.
Because on those switchbacks, the rain's coming which way? Straight down.
Yeah.
Right? So the rain just went and like destroyed all those switchbacks.
And there's so many of them, it's just like,
Yeah. It's wild down there. It's wild down there. But Lurch's Donuts did go down to North Carolina and give away free donuts.
Really?
Yes. Yeah, I know, they're so
That's
generous.
so cool.
That's why I support them.
I freaking love it.
I know, I got 2 weeks. I'll finish it, I promise. Yeah.
Chimney Rock, like I've been there before, and it's
I know.
not there.
It's wild. Okay. This is obviously a picture of the jet stream. All right.
Clearly.
This is the jet stream. I've got pressure uplifting. I've got wind. I've got wind here. If the wind is blowing this way, what type of pressure must I have on this side? Low pressure. This is low pressure. And this must be high pressure. This is how the weather works.
What does that say?
Wind. The wind is blowing this way. I've got low pressure over here. I've got high pressure over here. This is the jet stream. The jet stream is a massive amount of, just like a river of wind in the atmosphere that blows around. If you fly from here to California, and you fly from California back to here, which way is going to be faster? California back. Why? Because you're flying with the jet stream. All right? Wind generally blows in the northern hemisphere from west to east. You got it. That's part of the Coriolis effect. If the Earth stops spinning, what happens? If the Earth just stops spinning right now, what happens?
It gets really cold.
Nope.
Oh, that's always stay on one side.
We don't blow away.
Yes. If the Earth stops spinning, the atmosphere is going to keep moving. Well, the atmosphere, the jet stream is moving at like 30,000 miles an hour, right? Anything not connected to bedrock is just going to get blown off the face of the Earth.
Wait, so like we're gonna go with all the water and stuff.
Everything's gone. All right? It's going to get blown off the
So,
face of the
is the
Earth.
whole building gonna go?
I mean, I don't know. I don't know what would be left.
Let's see.
Let's try it.
Press the button, turn this off.
That'd be kind of cool.
Just all I know is thank you, Beyonce, before that happens. Thank you, Beyonce, before that happens.
So save us in a row.
Okay. Let's talk about units. We won't
Who's that now?
blow away. Yes. Thank you. Okay. So units. Units on that we're going to be talking about this chapter are
Time out.
one.
He doesn't know who Francisco Lindor is.
It's okay.
Former.
Former shortstop for the Cleveland.
I didn't hear what you said. I thought you
At
said
that point, it was the Indians.
You said Francisco Lambert, and I was like,
Francisco Lindor is the second best shortstop in the history of the Cleveland Indians / Guardians. Who was the best shortstop?
He's the best smile.
who was the best?
This is like pretty good, deep Cleveland trivia here. Omar Vizquel.
Duh.
Before, like,
Obviously.
yeah. All right. One atmosphere. One atmosphere can be converted to several different things. It can be converted to millimeters of mercury, which is 760 millimeters of mercury. This can also be converted to, Andrew was talking about this, I think, torr, 760 torr. One atmosphere, 760 torr, is usually related to STP. What is STP? Standard temperature pressure, which is 1 atm and what temperature? 273 Kelvin, which is 0 Celsius, right? That's freezing. Now, not to be confused with standard conditions. So standard conditions, this is what I said we would talk about a little bit later. Nathan said, what is room temperature? It's considered 1 atm and 298 Kelvin. You must know the difference between STP and standard conditions. The only difference is the temperature. So room temperature is considered 25 degrees Celsius.
So
Wait,
is
so-
that in Fahrenheit?
If you
I
live
don't
in
know.
a mountain, room
I don't think so.
temperature's higher.
Hey Siri. Hey Siri. Oh. Hey, what is 25 degrees Celsius in Fahrenheit?
25 degrees Celsius is 77 degrees Fahrenheit.
That's pretty warm.
Wait,
All right. Well, yeah, if I'm going to have Siri, she's going to be British.
Mr. Howard,
Yes.
so if you live in a mountain, is like room temperature different then?
No, this is scientific standard conditions.
Okay.
This is just what they accept as standard conditions.
So is STP like a lab? Can there's like that's like a lab setting and standard conditions is like their
a lot of the times you're gonna have a problem. They're gonna say at STP. So like if you're doing like a Boyle's law, like P1 V1 equals P2 V2, you know that your P1 is 1 ATM and your T1 is 273 Kelvin.
So if it
That's what we're
was
gonna be
like-
using that for.
And you do that in a lab, like standard temperature pressure.
You could do it in a lab if you could have just 1 ATM.
Okay.
Our lab is hardly ever 1 ATM because we either have high pressure or low pressure.
Okay.
Is there a specific, like, how much is 1 ATM?
It's 1 atmosphere of Earth. So, how do we figure this out? Here's Earth. All right? Obviously, United States. Some other things, right?
Obviously.
That's pretty good. That's pretty good.
I see Ohio, I see it right there.
Here's Ohio. Okay, I'm drawing a column of air. This column of air is 1 meter by 1 meter. So this is a meter squared. That is equal to 10,000 kilograms of air pressure. That is what we call 1 atmosphere. So on a 1 meter by 1 meter, essentially kind of like your desk, there's 10,000 kilograms of pressure pushing on you. Do we notice it?
No,
Why?
because we're used to it.
Because baby, we were born this way.
Bill, why are we so strong? Period.
Right?
Why are we Lady Gaga?
We're born this
Maybe
way.
Beyonce.
So
Why are we so strong?
now this is one of the issues if you've ever watched any space movies talking about babies being born in space. Will babies be able to develop correctly without the right amount of air pressure or the right amount of gravity? We don't know.
Wait, so what
I don't
happens
think
if there's
so.
less pressure?
We don't know.
I don't think so.
I believe Wally covered that. Have you seen the thing in The Expanse where they're super, super tall and they like totally combine just bringing them down?
Yeah.
That's why aliens are taller.
Yeah, right. Yeah. Now, here's the weird thing. If you want to believe in aliens, all right, which there likely there's some other kind of life form out there. Now, the closest star to Earth, it's like Sirius A or B besides the sun. If they were looking through a telescope, this is going to blow your mind. This has nothing to do with what we're talking about. To Earth, the light that is reaching them, what would it show on Earth right now? Dinosaurs. That's what they would see on Earth right now.
What?
Yes, because that's how far away it is from us. It takes that long for light to get there.
Isn't it like
Okay,
if the
what if
sun
they're so
exploded-
advanced that they found a way to make like
No, wait. Isn't it like if
Maybe.
the sun exploded, we wouldn't know for like for like
8 minutes.
8 minutes. Okay, that's right.
Yeah.
because we wouldn't see it, but it would like.
Right, because
Yeah.
it would. We wouldn't
Guys,
be
the
able
sun
to
might
see
have
it.
just
until-
exploded.
Thank you, Beyonce.
So they don't
The
even
sun
know
could
I
just explode and we
exist.
won't know.
So I'm like
Yeah.
Batman to them right now.
Yeah. So, anyways, it's really weird to think though that the closest star, they still think we're in like dinosaur times. So, kind of cool.
They don't even know about nanotechnology.
They don't.
Maybe they're not. They don't really.
They don't know that we know.
Maybe nanotechnology though, they're just like born with that knowledge.
Other conversions you're going to need. 1 ATM is equal to 101,325 pascals. And also 1 ATM in the English system is equal to 14.7 pounds per square inch. Pounds per square inch. That's a PA. Pascals. So units of pressure are torrs, ATM, millimeters of mercury, pascals. Last thing I want to talk about today is Graham's law.
Graham's law.
Graham's law. This is Graham's law
Wow.
of effusion.
I just put.
Graham's law of effusion
Graham like grandma.
Yeah.
is, it basically says, the more massive the gas particle, comma, what? The more massive the gas particle, how would you finish this?
More room it takes up. More pressure.
Higher.
The more mass of the gas particles.
The more massive,
The more mass.
mm-mm,
More mass.
The more mass, the more the
the slower they move.
Oh. You're really right class for sure.
So what is a fusion? A fusion is gas escaping through a hole. Gas escaping through a hole. So if I poke a hole in a balloon of xenon and I poke a hole in a balloon of neon, which one is going to, the same size pinhole, which one's going to empty first? Neon. Why? It's a lighter particle, right? Neon is going to effuse out much more quickly than xenon. There is an equation for this. Rate of effusion 1 over rate of effusion 2 is equal to, you guys ready for a really weird equation? The square root of molar mass of the second thing over the square root of the molar mass of the first thing. So it's a plug and chug equation. It's nothing like super hard. But that is Graham's law of effusion. That's also what I wanted to get done today. So tomorrow we're going to go and we're going to prove the gas laws. You guys have heard of the gas laws are what?
Fake, because I can.
Boyle, Charles, Gay-Lussac, yes. We're going to prove the gas laws tomorrow.